Hello, good day everyone. I'm Mrs. Amadeo Malmis. In behalf of Group 2 Set B, I will do the presentation of Electro CO6. The task of our group is to create a fully functional ladder logic diagram which is programmed to a PLC simulator that automates the process of a marine boiler. So, for the task, create a start button that manually turns on the feed water inlet pump. The key components are: input is the start button, output is the feed water inlet pump. PSIM function: press F5 to edit rung, press F2 to insert rung, press F1 as a normal open command, start button as an open switch. Press, press the F8 for output instruction, press F1 to address the output, and so on. For task 3, program a latch function in a start button. The key component is the start button is an input that relay the output. Relay the output, it means it's called a relay connected or the latch function. And this is the PSIM function K. Then third task is create a start button that manually turns off the feed water pump. So it's like a safety command. So every machine should have a stop if there's a troublesome in the process or in the machine. So always have a stop button. So the key components is: input is the stop button, output is the feed water inlet pump. Same again, PSIM function K is always in the press F5, press F2, press F2, and so on. Then for implement a safety system which prevent tank overflow. The key component of preventing the tank overflow is the input is the high level sensor. So every tank, like marine boiler, is a high mechanical use or a dangerous type of machine. It always have a high level sensor to avoid the preventing tank flow or the liquid substance to overflow. So it is always a normal close. Output is a feed water inlet output. So the PSIM function K is, as we can see in the next video after this. So this is the PSIM function, just log it. So next, so the wrong configuration of stop start button latch function prevent the tank overflow. So this is the stop normal close. As we said in PSIM program, this is the sign that we see. Then the start button, it's been wrong. It's a normal open, not a normal close. This thing, it's a normal open right there. This is a normal open. I get it is a wrong type. So below of the start button sign, it is the latch function. This is how the latch function of a start button. Then the high level sensor, normal close. It is a normal close also. It's another sign of a normal close, or in other words, the active function, which is if the high level sensors is turned on, the inlet pump will be turned off automatically. If the high level sensor is turned on, the inlet pump will be turned off automatically, like that. So for the task 5, program a run indicator lamp that lights up in the feed water inlet pump is running. So if the inlet pump is running, the light indicator will turn on or the green color. So the key component: input is the inlet pump normal open. It should be a normal open. The output is a green light lamp indicator. It has a normal open output also. So if the input is activated or turned on, the output also activated, which is the green light lamp. So the PSI function K, same process again. So this is the diagram of, that's it. These are the diagram. For the task 6, program a full indicator lamp that lights up in the tank is full. The key component input is the high level sensor. The normal open output is the red light lamp indicator. It means the high level sensor must be um, turned on, as the red light lamp indicator is turned on also. Light indicator red color is a full. It means full. So PSIM function K, just logically the same process. Just press F5, F2, F2, and then enter the type, the address, and again press F8 like that. So this is the diagram, logical ladder logical diagram of the prevent the light indicator turn on as along the high level sensor. So next, this the step okay, this the light indicator standby. So if means it is used if the tank is empty, the light indicator standby will turn on or emit a yellow light in a light indicator. So it means if you click the stop button, um, it's just like um, the light indicator will be turned off. It means you click the stop button. So for the task 7, program a boiler burner to automatically maintain the temperature of water inside the tank at the boiling point. Then set the boiler burner to not turn on if the tank is empty. The key point, usually the low level sensor is activated, burner or heater is activated, gauge temperature sensor also activated. The PSI function K is logically same process, press F5, press F2, press F2, press F8 for output, and press 10 twice for exit. And that's it. Just check if the configuration is correct. So there's another diagram here. This is the okay. This diagram is used for controlling the auto or automatic on and off burner or heater. Just this comparator, as we called 75 degrees Celsius, it's set in 78 degrees Celsius, and the low level sensor is activated. If the low level sensor is turned off, the burner will also turn off. So there's another diagram. Okay, this thing is the steam outlet output. It means another outlet output. This thing is a low level sensor that will the use of this low level sensor activated is if the low level sensor is turned off, it means the tank is empty. In other words, the steam outlet output will be turned off automatically, or and the use of this comparator the equals 75 degree is to turn on the steam outlet, is to allow the steam outlet to open so that the heat will flow is the heat will blow out from the tank and flow to the specific component after the boiler, marine boiler.